Hi everyone, welcome to the third video in the series Shape Memory Alloy Modeling with Marc Mentat. In this part, we are going to focus on super elasticity modeling, which is one of the key characteristics of SMA. This model is already available in Mentat. You just have to go to help, go to users guide, and here search shape memory. And you will find this is example number 52. If you scroll down and click on this green play button, the proc file will get executed and you will have this model in your Mentat. I did some changes, so it is not exactly same, but it is very similar. Let me expand all the folders. We have two boundary conditions. One is fixed and one is displacement boundary condition. For displacement boundary condition, we are using this table, which is shown over here. The table is defined up to 10 seconds, but we are going to use only first 2 seconds. We have initial condition, which is 35 degrees Celsius, and this is the material. To come here, we have to go to material properties, new, standard, and then over here in type, we have to choose shape memory. Let me delete this one because we already have one. Elastic properties are defined over here. Control parameters are defined over here. We are going with default value of maximum detwinning strain. And phase transformation stresses are defined over here. I defined the stresses at 35 degrees, which is the temperature at which we are going to perform simulation. Hence, value of CM and CA doesn't matter. But if you are performing simulation at some other temperature, which is not 35, then you have to define appropriate CM and CA values as well. Hope that makes sense. Then we have two load cases for 1 second each. And finally, job card. I have selected both load cases, all the loads. In job results, we are requesting equivalent von Mises stress and volume fraction of martensite. So let's submit the job. And what we are expecting now is as we load the wire in the areas where stress concentration happen, which should be over here and here, the material will start transforming to martensite. It will transform all the way to martensite as we come up here. And then when we unload, it should transform back to austenite, finally resulting in 100% austenite wire. Let's see if that's the case. Volume fraction of martensite, and then let's see. We are loading. You can see martensite is forming in these areas. This is the maximum load, and unloading. All the martensite is converted back to austenite. Another interesting way to see this result is history plot. For that, right click over here in result history plot. I'm going to choose a location over here, this node, all increments, and let's plot the volume fraction of martensite at this particular location with respect to time. Here I'm going to choose that location and variable is volume fraction of martensite. Add curve, fit. And we see initially there was no martensite. Gradually it transformed into 100% martensite and again back to 100% austenite. So that's all for this video. Feel free to reach out if you have any questions and I will see you in the next one.